Hi, I'm McGrath, and I'm talking today about generating types from JSON. So first, I'm going to talk about what is JSON and why we care about this problem, then a brief detour on type providers and a bit of the background there, then how I brought this back into Julia, and finally how we can actually take advantage of this and use this. So what is JSON? JSON is a human-readable data format. It has two main metatypes, container types, arrays, and objects. And then objects are key value pairs, and the values are a pretty basic set of integers, floats, strings, booleans, and nulls. And this JSON is used pretty much all over the internet. It's used as a pretty common data format, and it's also used pretty frequently in things like configuration files. And actually, this snippet I've been showing is from the Pretalks API, where Pretalks is the conference management program that JuliaCon uses. So before diving into how we're kind of generating types in Julia, I wanted to take a step back and talk about some of the inspiration for this work in Julia, which is the paper Types from Data, Making Structured Data First-Class Citizens in F#, which was published in PLDI in 2016. And this paper is really about the experience in F# of kind of creating types from data. They consider data to be JSON, CSV, and XML. I found the JSON kind of part of this paper the most compelling, and that's what I kind of brought over to Julia. But the core ideas of the paper are that there's a shape inference algorithm, which is proven to be relatively type safe. So basically the idea is that all structures kind of have a shape to them in terms of the keys, the values, whether it's an array or it's an object or record type. And then also those fields have types themselves. And relatively type safe is because it's inferring those shapes and types from sample data. And if your samples don't reflect well the kind of universe of possibilities of what could be in that data source, you could get an error at runtime. And the core of kind of how this algorithm is implemented is that you have, as you can see in kind of the top right, this slightly tricky figure, but I thought it's still useful to include it. We have that little kind of upside down T, which is our kind of placeholder type before we have figured out anything about what is in this data. And then as we review the records, we kind of go through and say like, okay, what is the type of this record? And then we kind of unify that with the other information we have from other samples to determine what is the ultimate type and what is the kind of the shape of the records that we are creating here. So heading from F# back into Julia, there are some differences in the design of the two languages, which kind of cause for some different interpretation of that algorithm as we try to implement it in Julia. So a big one is Julia is dynamically typed, whereas F# is statically typed. So whereas that was all at compile time and compile time guarantees in F#, in Julia, we don't have quite as strong guarantees there, and also in terms of how the types are implemented, we can either kind of write them to a file ahead of time as a module, or we can parse and evaluate them at runtime as well. F# also kind of doesn't have union types in the same way that Julia does, so it would go from kind of a string to, if you had a string and an int, to an any, whereas here we can use small unions and say union of string and int instead of any, and that is more efficient in Julia. F# also has kind of optional types, whereas I've chosen to represent those in Julia as the union of nothing and whatever other types are present there. And then, as with all kind of structs in Julia, they either can be mutable or not. Now that we've talked about what is JSON and how we can generate types from it, now we can get into how do we actually use this in Julia. So type generation has been added to the JSON3 Julia package, and there's kind of two main parts to the API here. First is JSON3.writeTypes, which will kind of take in your sample JSON, generate the types from it, and then write that to file as a module so that you can include that elsewhere in your code base. The other main way of using it is the macro JSON3.generateTypes, which kind of does the same type generation mechanism, but instead of writing it to file, will instead kind of evaluate it as a module in your current process. So you can immediately use that type. So a sample kind of use case for this might be there's an API that you want to kind of query, such as the Pretox API, and you get the sample piece of data there, you read that into a string, and then you pass that to write types, which will kind of parse that all out and figure out what is in there, and then write that module to the pretoxtypes.jl file. And what that file will look like is it is a module named JSON types. You can customize that. By default, the structs that it generates are mutable, but that is also possible to go for immutable structs. And you can see that it has a root, which kind of has what was about this talk, and then that references speaker. So there is also a speaker struct, which talks a little bit more about that sub struct. And then these are also initialized as struct types so that you can take advantage of JSON 3's already existing mechanisms for reading JSON into types in Julia. So in the last slide, I lied a bit. What the output I showed of that pretox.jl file is a simplified reality. So this is what it actually looks like. You see we have another type, submission type. There's a lot of fields that I omitted so that it looked nicely like the sample JSON I showed earlier in the talk. And you might notice there are kind of a few issues with this. So for a lot of these fields, like track or resources or answers, where there just wasn't much information, it was either null or is empty arrays, we don't have much information about what these values are. There are way more fields here than I honestly care about, and I don't want to pay the penalty of carrying those around in memory if I read a whole file, a bunch of these into these types. And also some more nuanced logic isn't quite captured. So often in JSON, you'll find that the value of a field then dictates that another field might exist and have certain values. And this algorithm just can't capture that sort of nuance. There are some solutions to this. So one, give as many samples as you can and is reasonable, because ultimately garbage in, garbage out with this sort of work. And then also, I like to treat the type generator more as kind of a reasonable starter type, which I then edit to make more compact and nuanced and correct based on the kind of outside information I have, instead of just using the types as is. So the takeaway for today is that we can stop writing artisanal types for our JSON. The type generation in JSON 3 makes a pretty good attempt at getting a starter type, which then you can then polish instead of starting fully from scratch, which I find a lot easier. And I want to give a thank you and a shout out to Jacob Quinn for kind of helping me incorporate this work into the JSON 3 package.